Thank you, Emily and Kate. We have a question here. We've had a heat spell and avocados are very susceptible to heat. How does soil health play into a more resilient orchard uh, when it comes to heat damage?
Okay, you unmute yourself.
Emily, I think you have a better grasp at that. Yeah, it's a question.
Yeah, so I mean, there's the whole water relation, right? Of between the soil and the plant. But I think in terms of heat, what we're really seeing is the impact of some of the practices, such as cover crop, for instance, to cool down the canopies. We have new results coming in. We've been wondering about the water impact and the water usage of cover crop and the ET requirements, etc. In this Sigma era. And through that process of doing research using flux tower, etc., we measured that actually an orchard that has a cover crop and more water infiltration, the canopy is cooler. And so at the end, over the length of a growing season, you have some kind of somewhat the same ET, whether you have more biomass with cover crop or bare soil. So there's an indirect functions of soil and heat just through water supply, but there's also a very direct relationship with cover crop and some other soil health practices that cool down the soil and cool down the canopy as well.
Yes. So here's a question that every grower is probably asking right now. What are the financial consequences of implementing soil health practices on my pocketbook? So is there a direct link between cover cropping and increased productivity? Is there a dollar per dollar comparison of different practices that are going to increase well, one of the questions should be the longevity of my orchard. So a healthier soil presumably is going to make a healthier tree, which is going to be producing longer. But how do you put a dollar amount on soil practices?
Well, this is a very difficult question that economists are grappling with. So there's a model, for instance, that puts a dollar value on different ecosystem services. And kind of look at the return on investment from some of those practices and soil health. And so in general, what the models show, and we're talking about almond here, I'm sorry, I don't know enough about avocado to be more deterministic here, but the return on investment on cover crop is about 5 to 7 years. But it also depends as to what cover crop you use. So a cover crop can cost between nothing, which is like I have a bag of I don't know, oats or wheat at the back of the barn, and I'm just gonna put it in my alleyways, up to $150 an acre if you want some California wildflowers, right? So cover crops can be very costly, or they can go, yeah, you can have a cover crop mix for about $10 to $15 an acre without counting equipment. I think the increase in productivity are mostly seen in orchards that are very degraded. And so you can definitely cut on your ripping, on your gypsum, and all of those other inputs that you might be applying if your soil is really on the other side and mostly degraded. So yes, there is a cost of implementing soil health practices. It's a long-term investment, but so are trees. And we actually have now some research looking at not necessarily the longevity of the orchard, but rather can I start going into production earlier? And this is kind of what's popping up out of the research, at least in almond. If you have a healthy soil, you might be able to harvest a year before. And so kind of prime your return on investment a little bit earlier in in the lifespan of the orchard. So that kind of answered the question, but not so well. But those just because we don't have good data from economists quite yet. And they put dollar values on other things, right? What's the dollar value on a bee, right? And so we're starting to be a little. It starts to be complex when you want to value ecosystem services and not accounting for double dippings.
Okay, so here's some very specific questions related to avocados then. Almonds and avocados both start with an A, but they're really different.
Yes.
So avocados are grown on slopes, very steep slopes oftentimes. They are big trees that shade the ground and they create their own mulch, their own native leaf mulch. So what specific cover crop species would you recommend in a shady, high mulch environment on a steep slope where it's hard to get machinery in to mow? So
Yeah.
you've got a steep slope, shade, and native leaf mulch.
Or there's a plant for every situation. But I think some species that might do well are the clovers. The clovers are shade tolerant. They are low stature. So there's a variety of clovers, right? But there might be a good entry point. But it also depends on what is the objective of that cover crops. Often we like to have mixtures. Out of our research, we're finding that mixture between 6 and 8 species kind of hit a spot in terms of making sure that the cover is stable. Cover crops are going to look different every year. What you plant is not necessarily what you get either. And so there's a degree of being flexible with what that look like, and it might not be exactly what you planted in terms of the different mixtures. But I would recommend in this case some low stature clovers and mixes with, if brassica get pretty high, and so if mowing is really a problem, I would potentially choose those lower stature ryegrass to mix it with. I think a legume and a cereal go well together. And then we've been experimenting with California poppies that do extremely well as cover crops. And we're trying to look at what do those roots do. So I've been interested in those white flowers, but they remain pretty expensive to set up in an orchard. Some other options that are coming on the market are the Oakville bluegrass, for instance. Those are cover crops that are very small, that do not need to be mowed, and they will be shade tolerant. I'm not sure how much they can exist under that leaf layer. Because I haven't tried it personally in an avocado system. But the particularity of this Oakville bluegrass, which is cool, is that it will die off in the summer, and it will regrow with the first rainfall. And so in some systems, such as almond, it's valuable because we harvest off the ground. But if you're concerned about not wanting to water your cover crop and lose water, those are some good option, the Oakville bluegrass as well. So yeah, the diagnostic and the type of cover crop to be used has to be discussed on site, but there's various options for those systems. And finally, I'll finish with resident vegetation, which are the native cover that you have in your orchards. What we find is that sometimes you're going to spend a lot of dollars planting a cover crop, and the difference with what you would get in terms of soil health improvement with the resident vegetation that is well mowed and well maintained is not very large. So sometimes just working with what you've got in your orchard as native species that are adapted there it is a good solution.
That's a good point. Cultivate your weeds.
Cultivate your weeds, yeah.
Yeah.
The microbes is not gonna, the soil biodiversity doesn't care if it's a weed or not.
Yeah, right. So one of the attendees, John, says, don't plant covert, brings it clovers, they bring in gophers.
Yeah, I agree. It's so, and thank you, John, because that illustrates the conundrum. There's always going to be a trade-off. Okay. Sometimes the gopher is a problem, sometimes it's a nematode problem, and so it has to really be orchard specific. It's not, the gopher is not a problem everywhere. I've seen growers swear by clovers, and I've seen others being like, I don't want clover for the gophers or the ground squirrels, and so it also depends of your type of irrigation. Are you on a drip system, or do you have more flexibility in terms of irrigation? So yeah, a lot of consideration, and there's always a trade-off, and that's the nature of things.
So you haven't mentioned any sort of amendments like biostimulants, kelp, humic acid, fungi that you apply, mycorrhizal fungi. Are there any things that growers can buy that they can inject through their irrigation system that is demonstrably going to affect soil health?
Kate, do you want to take that?
I can start, and then you're more practically oriented with it, Amelie, but there's a lot of things people can buy.
Yeah.
And there's a lot of efficacy issues, I guess, with it. I mean, partly a lot of the products aren't tested, and yeah, there's a slide we put together in anticipating issues with inoculants is, I mean, so just more generally, often the issue is not that the organisms aren't there. The issue is there's something about the conditions of it that are not allowing organisms already there to do what is needed. And then, yeah, often who you add is a bacillus that stores well on a shelf. You know, there's a lot of bacillus in inoculants, but they're not known to be big players in soil. Often they're going to drop dead because they don't know how to live out in the environment. How do you inoculate them? Do you get them to where they need to be? Soil is this enormous, vast frontier, and where you need the work to happen is not generally broadcast, but needs to be in place, which is why some of the inoculants of seedlings in greenhouses before you put them into the field is a good place where there are some benefits. There's a lot of been studies showing that predation can wipe out the inoculants very quickly. If you think about it, they're just dropped in the soil. I think of like New York City, like there's a lot of organisms already living in apartments and homes, and then you drop the inoculants are sort of dropped into the streets, you know, and maybe in the middle of the night, you know, so they're just walking around being preyed on by whomever is there. You know, they don't know, they haven't figured out where to live or how to survive. And yeah, then there's issues of doses, right? And how many times you need to add them. And yeah, this last point is that a lot of inoculums are developed to be able to produce a lot of them. They're not developed to be able to endure soil. So there's a lot of failures of inoculation, but that does not mean that it doesn't work. And it has been beneficial to people. Oh yeah, and I also want to just bring out the probiotic versus prebiotic versus probiotic idea that we also have with humans. Do you take additives to be able to enhance who is already there, or do you actually put the organisms in directly? And so there's a lot of analogies between soils and human gut in that. But there are situations where I think there have been some benefits of inoculation. So I'm just being very, you know, critical, like with this of just looking at the big picture of why they often do not work very well. But there are people that have have experienced benefits from it. Amelie, you might want to say something. You've done some work on this.
Yeah. Well, and I think there's also an expectation like, oh, I'm gonna put this inoculant in and I'm going to see some benefits to my tree. And that might be true in a system that might be not plentiful in terms of resources. But I think, expecting that a mycorrhizae is going to bring a yield bump in a system that has sufficient water and nitrogen, etc., is actually an unrealistic expectation. Those inoculants might work better under stress, or when something is not optimal. But the only experience I have with inoculant is with mycorrhizae. And we compare orchards that were inoculated versus non-inoculated. And then we looked at a bunch of practices. And in a nutshell, whether you inoculate or not, mycorrhizae are going to be there. They're ubiquitous. And one of the most important practice to maintain mycorrhizal colonization was not inoculation. It was actually having living roots in the systems. So the more soil cover you had, the more colonization rates you had, whether you inoculated or not. And so the conversation is a little bit more complicated, as Kate mentioned, especially when it comes down to mycorrhizae. And I won't go into the details of who is there, but there's an amazing diversity of type of mycorrhizae. Some of them are cheaters, some of them are beneficials. And so we're just scratching the surface when it comes to this inoculum as to what they can do. I think eventually some of creating the habitat and the resources for biodiversity to thrive is probably more cost effective on the long run than taking the input-based perspective where you're not very sure whether they stick around. I'm seeing a lot of inoculum companies now switching their narrative because we have seen very, very valuable results across the landscape. Instead of being a plant inoculum, it is now a soil health inoculum. And so they're trying to kind of repackage this as a way to add carbon to your system, add fungi, but without really emphasizing so much the plant outcome. But if you dump a mycorrhizae on a bare soil, it's just not going to make it.
It's a very expensive carbon input.
So it's a lot about the practices, I would say.
So this brings up, what about yucca extract and seaweed extract and humic acid and some of these other things? What about purchasing an organic fertilizer versus a conventional inorganic?
And there's a question there about that.
Yeah.
Yeah.
Do you want to answer it?
Amelie, I think it's more, it has to do with organic. I mean, all I can say is organic fertilizers include carbon. And often that is a limiting thing. So when you're just using synthetic mineral fertilizers, they're not getting the benefit of having carbon also be put in them. But carbon could be put in another way, could be put in consort with the synthetic fertilizers. But that's one thing about organic fertilizers is there's other benefits than just the NPK kind of aspect. But yeah, it doesn't mean that that you must use them. But Amelie, I'm sure that you have thoughts about this.
No, I mean and any additional sources of carbon, and this is what the promise of humic acids are, is just giving some food to the microbes. So fostering this, if you give food to a somewhat dead and not diverse ecosystem, I mean, I'm not sure how beneficial it's going to be, but if you've created the conditions for the biology to use those carbon sources that are very labile, it might be beneficial. We haven't seen any tangible benefits from humic substances. Some of the annual growers we work with, Kate and I, thinking about Scott Pack, who swears by seaweeds. He's an annual crop grower, but he's brewing his own microbes, and he just really like having his seaweed in the transplanting rows, especially on tomatoes. But it's not something that we've extensively tried in orchard systems.
So what about a yucca seaweed extract? You're adding carbon, is it economically beneficial?
Isn't it a very low carbon input though? I would think.
Yeah. Yeah,
But I mean, if it was just for the carbon, but there's probably other things in them.
oh, yeah, that's the problem. There's other things that aren't quantified. So here's the, this is a Mediterranean climate, and if you're gonna make money, you're gonna irrigate. So where does water play in this soil health model? It's just been mentioned in passing, but it's probably the major input that we have in agriculture here.
Well, soil is a living ecosystem, and so it needs water. Okay, microbes are gonna need water to thrive. Plants are gonna need water to grow. So there is a water. There's definitely a water conversation here. Some practices require more water, some don't, and there's also how you manage them. I talked a little bit about cover crop and water usage. Bare soil lose a lot of water through evaporation, and you get very little benefits because you don't produce biomass out of it. And so there's a potential to realize with cover crop here in using that water productively to foster soil health while cooling down the orchard. So eventually the ET requirements remain similar. But we see, for instance, a very cool impact of mulching, etc., into lowering canopy temperature, lowering soil temperature, and all this kind of help prime and keep soil biology active. So it's a system that kind of going to self-regulate. You're going to get more water infiltration, more water conservation. That will prime more soil biology, which will improve soil structure and eventually water retention. So you're priming this positive feedback loop rather than the reverse. Now, the problem at the state level right now is that we have policies that are not aligned. So you have a healthy soil practice, healthy soil program that is going to give incentive to growers and pay cost share for some of those soil health practices, including cover crops. And then on the other side, you have SGMA regulations that are going to dog growers for having green vegetation in the summer or later in the season. And so we're having a lot of conversations right now to try to get more data so that we can inform those water budgets. But we see more benefits in a system that has that he's moving away from just these spoon feeding drip systems where if you're gonna wet just this area, the microbes that are away from this wetting zone are gonna be dormant and not so active, especially if you don't have living roots. So yes, there's a need for water to build soil health.
And there's that trade-off, right, between just giving water to the plant rather than giving water to who else lives in the soil. But that's another trade-off, right? But that a lot of the life in the soil will be just on the shelf, will be parked. They're very good at like enduring long periods of drought in California, but they're not doing anything. They're barely active. So that can even happen in a drip irrigated system as you move away from the drip line, that soil is not functioning very much.
What about the salinity in water? What impact does it have on biodiversity and activity?
Yeah, I mean, if it's excessive, it definitely can reduce microbial biomass and all, but I don't know a lot about it in a California ag context. Emily, have you?
Well,
Yeah,
yeah, I mean, there's a sweet spot there where salinity is really going to be detrimental to microbial activity, and that's mostly through shifts in salinity and pH, etc. So there's those can have a large impact. Now, you're going to find microbes everywhere. Okay, there's some microbes that can totally tolerate salt marshes, right? I'm not a saline soil is far from dead, but it's not necessarily what we want.
that's sterile. It's not sterile, it's sleeping.
Mhm.
Biochar, where does that play a role in soil health?
I can say a little bit about that. We've done some work on that in, more annual cropping systems, and some pretty intensive studies showing at typical application rates, no benefit or very little benefit on attributes on some of the soil health properties, but also on cropping systems, but maybe a little bit more benefit in very sandy soils rather than in the like Yolo silt loam, like some of the soils that we have around our valley. There's other reasons to put biochar in. Biochar is inert, but it's not completely inert. It actually does provide some carbon, but I don't know. There's been a lot of work done on it, and I think it might help in carbon sequestration as a place to put a way to put some carbon into your soil for just building the carbon content. But and also biochar is a great thing to do with waste products. For example, maybe sewage, biosolids from sewage, and get it in a form that's safe to be able to put into the ground. So I think there's a lot still to explore with biochar.
That brings
And
up
then
the question.
I'll just add that most of the research that is done today in orchard system on biochar is bioactivating biochar. So you're gonna mix your biochar with compost, for instance, so that you get a little bit more biological activity with that input. So that research just started a couple of years ago. So it'll take a minute to get some results as to the impacts.
So food safety it comes up, running animals in an orchard. What
Go
about?
for it, Amelie. Go for it.
Yeah, go for it, Alan.
Yeah, so food safety is the thing that has been on our mind. So some growers do it. We have regulations in place from the federal government as to how long you can have fresh inputs of manure in the system before harvest. That holds for having animals, but also having fresh manure amendments. So it's anywhere between 90 days and 180 days. Before harvest, you cannot have animals in the orchard. We're collaborating with the vet school to make sure that we're giving those policies are informed by science. Right now, those numbers have come from research in different type of systems. But you graze, there's a potential to have E. coli and Salmonella contaminations. You don't know if the sheep are clean, but what we see is that the more biodiversity you have in your soil at the beginning, the less potential for those outbreaks you might have. It's pretty much like our gut microbiomes. If it's diverse, you might have less chance of having E. coli take over or yeast take over, just because the diversity of organisms keep everyone on check. And you've got self-predation, so the system kind of auto-regulates itself. But nonetheless, really something that is really important to think about. I think we're coming up with good numbers to have this practice being implemented safely, and mostly learning from growers who've been doing it.
Okay. Well, here's the last question, and it's for Kate, and you've just answered it. But if the Cornell assessment is not so good for Western soils, what assessment tool would a grower in California?
Well, there isn't really anything quite like that exists for the West. The parameters that are measured, the indicators, I think, are relevant. I mean, there's some that we are more important in the West than in the Northeast in terms of the parameters you measure, but most of them are going to be the same. The issue is in how you interpret it, is in that the scoring function. And to get to those scores, it requires a lot of work on collecting a lot of data on these parameters, and coming up with those relationships. I know that I think Toby O'Gene has been working a little bit on this. Amelie, I don't know if you know more about this in trying to sort of develop it isn't going to be exactly parallel to Cornell, but a more regionally specific and relevant soil health assessment framework. I'm calling it a framework. It's like, how do you then take the results and come up with conclusions?
And Toby's group and colleagues have really been busy trying to get the more data that we can from different environments and systems here in California so that we can calibrate those curves that Kate talked about with our unique environment, semi-arid, irrigated environment. So they're collecting data to run those models to see like, well, what's the upper limit and what's the lower limit of a specific indicator in our systems. And there is a new professor of new extension specialist in soil health that has been recruited in the department here at UC Davis, and she'll start soon. And her main job will be to figure out an assessment for California.
And what's her name, Amelie? I'll write it here.
I'm not sure it's public, so quite.
Oh, yeah, okay. Let's just. Okay, but Toby O'Gene, I put his name.
I'm gonna hold it.
I put Toby's name in the.
Ask Toby. He's in charge of that recruitment.
And would be collaborating with her, but I think.
But I'm sharing with you that there will be
an
extension specialist, statewide specialist for soil health, and whose job will be to develop a framework and calibrate indicators for California based on data we have and the new data that will be acquired.
And of course, California itself is quite diverse. So, and Toby's talked about this, like the watersheds, soil health sheds. So how do you group California into these kind of units that you can develop indicators and scoring for those areas. Yep.
Well, it's 10 o'clock. We made it. And we just scratched the surface. So thank you very much. Mary Lou, you have anything to add?
No, just thank you to our speakers. Thank you for everybody who hung in there for 2 hours. We really appreciate it. And so we'll see you at the next Avocado Cafe, hopefully very soon. You'll get a notice from Lorena. And thank you again, Lorena, for all your help.
Thanks
Thank you.
Thanks, everyone. Appreciate.
Yeah, thank you.
Thank you. Have a great day.
Bye-bye.
Bye-bye.
Bye.